Okay, here is simplifying, multiplying, dividing rational expressions. This is part 2 of our rational expressions unit here at the end. So this is a good unit for brushing up your factoring skills, which you'll need a lot in future math courses. So anyway, multiplying or dividing rational expressions. We just learned what a rational expression is. And it's a polynomial over a polynomial, basically, in fraction form. If you multiply two fractions, just like you always have known, if you have a over b times c over d, that's just the numerator a times the numerator c over the denominator b times the denominator d. So that's how you multiply fractions. Is you just multiply numerator times numerator, denominator times denominator. We have a condition here that b cannot be 0, nor can d be 0, because we don't want division by 0 here. Now, you don't just leave fractions in this form. You are supposed to reduce them if there's any common factors to be reduced out. So you always, when you're working with fractions in math class, and also sort of in math in the real world, you want to make your expressions as simple as possible, depending on what you're going to be doing with them next. So we are going to go over reducing them, not just multiplying them. And then dividing is really similar. If you have a over b divided by c over d, that equals a times d over b times c. So I maybe could have an intermediate step here that shows that a over b is the same as, divided by c over d, is the same as multiplying by the reciprocal of the fraction that you were dividing by. So please note that where I had a d before is now up here up top, and the c here was now here. And then that results in a times d over b times c. We have the condition that b cannot be 0, c cannot be 0, and d cannot be 0. We also have to throw in c can't be 0, which we didn't have here because dividing by a fraction throws c in the denominator, and that we don't want a 0 in this spot here. You might say, why do we have to have d not equal to 0? Because the starting problem had a d in a denominator for whatever this might have come from, and this would have been c over d would have been an undefined number if d had been 0. So you wouldn't proceed if you had a 0 in any denominator anywhere. Okay, so most of what I'm going to ask you to do on your homework is practice multiplying, dividing rational expressions. So this first one, numbers are technically rational expressions. A 5 is a polynomial. It's a really simple one. It doesn't have a variable, but it is just like the constant part. So anyway, just a quick review of division. 5 over 8 divided by 25. You can think of 5 over 8, I'm just going to rewrite this, divided by 25 over 1. 25, you never write the over 1 when it's just a number, like an integer, but technically it's over 1. That helps you know what to do with the division rule here, and we're going to rewrite this as 5 over 8, so that the division sign becomes a times sign, and we're going to flip the second fraction here and make that times 1 over 25. So divided by 25 is the same as multiplying by 1 over 25. All we did was flip that second fraction. And then you can multiply these, but don't ever multiply these out when you know you're going to have to reduce. This does equal 5 times 1 over 8 times 25, but what we really want to do is look for common factors to reduce out. I'm going to factor this. You probably don't need to do this with numbers. 5 times 1 is 5. That you can multiply out. But 8 times 25, I'm going to raise 8 times 5 times 5. And I did that because I know there's a 5 factor in the top. Those 5s reduce. One 5 with one 5. You don't reduce the 5 with each. There's only one 5, a factor in the top, so it's going to reduce with one of them in the bottom. That leaves you a 1 in the top and an 8 times 5 in the bottom. In this case, you can multiply that 8 times 5 together, and you get 1 over 40. So that's what this problem equals. 5/8 divided by 25 is 1 over 40. What that means, by the way, just remember what division really means is, if you multiplied 1 over 40 times 25, you would get 5/8. That's dividing 5/8 into 25 equal parts. Okay, that's that problem. Now let's look at the next one. little more complicated. We've got variables. Notice there's no plus or minus signs here, unlike these later ones. So this we're going to largely handle like you did when you were simplifying using exponent rules. We're just going to look for as much reducing as we can. Everything's multiplied here. If it helps you, you don't have to do the step I'm showing right now, but some people like to do this step to make it one fraction. That's fine. So it's 5x squared times 21y all over 3y times x squared. What we're really going to look for is things to reduce. I can see this is all multiplied. It's 5 times x squared, which is really 5 times x times 21 times y. Yes, and this was my final answer. I need to put that 21 in front and combine it with the 5. I'm not going to multiply 5 times 21 though, because I can see a 3 factor lurking here in the 21 and 3, and we're going to be reducing that out. So everything's multiplied. This is 5 times x squared times 21 times y. This is 3 times y times x squared. We've got a y and a y here. Those are going to reduce out. And what's left behind is a factor of 1, by the way. What else do I see? I see an x squared and an x. Those can be reduced. That's going to leave a 1 up here. And think about it. How many x's are left in the bottom? We factored x times x out. That leaves us x squared here. Let's keep going. I don't see any factor of 5 in the bottom, so that 5 can't be reduced, but the 3 and the 21 can be reduced. And that 3, there's a factor of 3 here, and there's a factor of 3 in 21, and the remaining factor of 21 is 7 if you reduce a 3 over 3 out. So let's look at what's left. I have 5 times 7 in the top, all over x squared, and that equals 35 over x squared. And that's my answer. Okay, so there's that one. Now we're going to move into these last two that are a little more complicated. This is a rational expression. This first fraction is 4x over 5x minus 20 times x squared minus 6x plus 8 all over x squared minus 2x. Please, please, please follow along and do yours this way. You can multiply 4x into this and distribute it, and you're going to get 4x to the third minus 24x squared plus 32x. Please don't do that, because you're going to have to factor it later anyway and take that 4x both out. When you multiply two fractions, you don't want to multiply everything together. Just remember the rule is that it's 4x times, I can just make a single bar here and say this is 4x, if I want, times x squared minus 6x plus 8 over 5x minus 20 times x squared minus 2x. But don't FOIL the bottom and don't distribute the 4x in. I don't want you to do that, okay? Because you're going to have to factor it back out anyway. In fact, you really don't even need to do this step, and I would encourage you not to if you feel comfortable with the way I'm about to show you. We know we're going to be looking for common factors to reduce, so I'm going to try and factor everything as much as I can. 4x, I'm going to leave that as 4x. That's just a single term. You can't break it into much more other than 2 times x. But the bottom of this, though, I can take a 5 out of both parts. So I can rewrite this as 5 times x minus 4. All I did was factor a 5 out. You should always be looking for monomials you can take out of a whole numerator or out of a whole denominator. Times, now I'm going to work with this second fraction here. There's nothing I can take out of all three terms. You can take an x out of the first two, but that's not going to help you. You got to be able to take it, like here, I can take a 5 out of everything sitting here. That's why, and I took it out. But this is a trinomial, and I can factor it into two binomials. I'm going to put an x and an x here. I'm trying to factor x squared minus 6x plus 8. I need two things that multiply to plus 8 but add up to negative 6. That's going to be minus 4 and minus 2. If you think about it, that will work if you FOIL that back out. So that's the factored version of that numerator. In the bottom of this one, it's not a trinomial, and it's not a difference of two squares, but there is an x factor here I can take out. So I can take this x out, and that equals x minus 2. So I'm going to continue to get rid of that. Okay, so I could have factored these in this form and had all these factors written out, but you don't need to write this step. You really just say, my approach is going to be, I'm going to factor everything. every numerator and every denominator, and then look for some common factors, knowing the product of these two fractions is this, the 4x times the x minus 4 times the x minus 2 all over 5 times x minus 4 times x minus 2. So let's look for common factors. And just don't forget that there's a time sign between everything. Well, I am going to write intermediate step here. But again, I don't care if I don't see this step because a lot of people are comfortable reducing right here. But as a single fraction, this is 4x times this numerator is 4x times x minus 4 times x minus 2 that you don't distribute this in. It's just the list of all the things that are multiplied over 5 times x minus 4 times x minus 2. Oops. That x is that x, and it's just multiplied. It could be put in front here with this x if you want, but this is just saying these are 4 things that are multiplied. 5 times x minus 4 times x minus 2. And all I'm going to look for is common factors. I've got an x minus 4 factor. That leaves a 1 and a 1 on the top and bottom. I've got an x minus 2 factor. That's going to be that and that. And what else do I have? 4 and 5 are those don't reduce. But there's an x, this x, and this x reduce, leaving no x's behind. So this whole thing becomes 4/5, believe it or not. Because as it turns out, all the things involving x had a common factor in the top and bottom. So that's 4/5. And that's the answer. If you could reduce the number part of this, you would need to. Now let's look at this next one. This is, as you can see, 2x squared plus 3x minus 5 all over 6x divided by 2x squared plus 5x. Now, just like this number one up here, I'm going to view 2x squared plus 5x as something over 1. It's not under something, but since it's a division, your first step is convert it to multiplication. So it's 2x squared plus 3x minus 5 all over 6x times 1 over 2x squared plus 5x. So what I did here was rewrite the division sign as a times sign, and what it did was flip this fraction. So that flipped this second fraction. Okay, that was my big change. Now I'm going to do the step here. I'm going to factor everything that can be factored. This numerator has a trinomial. I'm going to go for factoring that. To get this 2x squared, I need a 2x and an x. To get the negative 5, that's going to be a negative 5 and a positive 1 somewhere. But I need a 3x here. So I'm going to put 5 here and 1 here. And I want a plus here and a minus here. That's going to give me negative 5 is my last term, but my middle term will be plus 5x minus 2x. So that's going to give me the plus 3x. There's a separate video on practicing factoring by grouping. If you need to pull this aside and do it by grouping, you should do that. And then, put those factors in this numerator. But I'm not going to, that's a separate thing to review if you need to. And then my 6x, I'm going to leave a 6x. This last one is 1 over 2x squared plus 5x. I can take an x out of both of those terms, so I'm going to do that. 2x plus 5, and everything's factored as much as possible. Now, just like up here, I can rewrite this as one fraction where I have this times 1 all over 6x times x times 5x, 2x plus 5. You can do it that way if it helps you see the factors. I'm going to reduce this one without doing that step, just to show you straight up. But these are 2x plus 5. That's a factor multiplied into my complete numerator in my complete denominator, and those reduce out, leaving a 1 behind. This x minus 1 cannot be reduced with this x because they are not the same factor. This is an x multiplied in, this is an x minus 1. They are not the same. It would be like having a 5 in the top and a 6 in the bottom, one apart. They aren't the same, they can't be reduced. So what we have left, and the 6x can't be reduced with anything that's sitting here. So what we're left with in the top is 1 times x minus 1 times 1. That's just x minus 1. In the bottom, I have 6x times x. That is 6x squared. And that's my answer.